Consider the velocity time graph below relating to a model car running on a track. Calculate the total distance travelled during this motion. Now we've got two sections that I can see quite clearly here. One while it's going upwards along this curve, and then the other one where it's going downwards. Now we want to get the area, and the best way to do this is by counting squares, because we need to know what each square represents. So it looks like it's 1 square to 1 unit going this way, so that's going to be 1, but going upwards it's 2 squares, so that's 2. So each square is 2 units, and in this case of course that would be meters, because the velocity is in meters per second, the time is in seconds. So each square is 2 meters. What we want to do is count the number of whole squares. Now we can block off sections, so I can see, for example, that rectangle there. We can see that that's got a width of 18 and a height of 20. So we can do the area of that whole bit as 18 times 20 is 360. And we could probably do the same sort of thing again. We could block it off into much smaller bits than I'm doing. And that one there, I can see the width. So this is at 6 going to 20, so the width there is 14, and the height there is 10. So this would be 140. And we could even do that again up here. And we can see that that goes from 14 to 20. So that's going to be 6. And the height of that one is, so that's 30, 32, 34, 36, 38. So it's 8. So this bit would be 48. And then we're going to count some squares, and if the square's completely in, we count it. And if it's more than half in, we count it. So whether we count this one or not would be a judgment call. This one would get counted though. I'd count that one, and of course all of these are in. I'm not sure I'd count that one. This one I would. This one, judgment call, I'm not going to count it, but you might. And that one, I think I might count that, and I would count that one, but not the one next to it. This one's more than half, and then of course all the whole ones, we need to count those, and that one's more than a half, this one's more than a half, so it's that one. Wouldn't count that first one. Second one I would, and then all these ones down here, and I'd count probably to there, and then that one will be a judgment call. So how many dots did I put in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So 48 squares, each one is counted as 2, and that makes 96. So the area for that part is going to be 360, add 140, add 48, the bits that I blocked off, and then add the 96 there. So that would be all of this area counted. And then we have to count this other area. And I might just count squares in there. Now, I wouldn't count any of these as being half a square until I get to here. That one just there is debatable. And then I would count all of these. And I missed the square on a couple of them, but I've got the right number of dots. I wouldn't count that one. I'd count this one. I wouldn't count the one above, or that one. I'd count this one and this one, this one, this one, and probably that one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So 34 times 2 is 68. So our total distance is going to be the sum of all of those. So we've got 360, add 140, add 48, add 96, add 68. And we'll give that as 712 meters.